In this video, we're going to be looking at a problem on angular momentum. Pause the video now and try all parts of this question. So in part A, it tells us to calculate the angular momentum of the motor. So what is angular momentum? Angular momentum is the moment of inertia times by the angular velocity, or momentum is mass times velocity, the non-rotation equivalent. So we need to work out what the moment of inertia is. Well, we've been given that. We need to work out what the angular velocity is. We've been given this, but we don't want this. We want it in radians per second. So 1500 revolutions per minute is going to be equal to 1500 times by 2 pi to get it into radians, and then not per minute. We want it per second. So we need to divide it by 60 to get only a 60th of that. So now we can work out our angular momentum. 0.56 times by 1500 times by 2 pi over 60, which is going to be equal to 87.9 Newton meter seconds, or any equivalent unit. It's fine. The motor is now connected by means of the clutch to the flywheel. So what's happening is this is going to be joining together. So it's now one big connected unit. The moment of inertia of the flywheel and drive shaft is this. So it's increased from this. Explain why the speed of the motor falls. So angular momentum, just like regular momentum, is the same before and after. So it's the same before and after. So I initial omega initial is going to be equal to I final omega final. So what's happened here? The angular, so the moment of inertia is increased, so therefore the angular velocity must decrease. So if moment of inertia increases, then angular velocity decreases. And then we're going to be using that in the next part of the question to work out the common angular speed. So we are going to be using exactly the same idea. I final, omega final. Well, we've already worked out the initial one, 87.9 Newton meter second. The final moment of inertia is 0.94 plus 0.56. All right, because the flywheel and the drive shaft, this bit here is 0.96, and we already knew what this was. This was 0.56. Now it's joined together. It's one big unit times by the final angular velocity, which gives us 58.6 radians per second. Calculate the angular impulse. So angular impulse equals the change in angular momentum. So just like impulse is force times time, which is the change in momentum, if it was non-rotating, it's exactly the same or similar for rotating systems. So 0.94 times by 58 equals 55.1 Newton meter second.